Our next competitor is Jacob Medina. Jacob is a doctoral student in the CCS program in cancer biology. Jacob's presentation is entitled Photothermal Therapy of SM1 Melanoma Utilizing Anti-CD137 Coded Prussian Blue Nanoparticles. It's a mouthful. Go ahead.
Hello, everyone. My name is Jacob Medina, and like Nicole said, my thesis is a mouthful. So let's start from the beginning. Cancer is a disease that can affect 100% of the world's population. Cancer is most characterized by the uncontrolled multiplication of cells and the camouflage of those cells from the immune system. It's that camouflage that makes cancer so notoriously difficult to treat. In fact, untreated cancer or unsuccessfully treated cancer can then spread throughout the whole body and become fatal. Today for my work, we're going to be focusing on melanoma. Melanoma is the cancer of the cells in your skin that give it color. My lab's approach to cancer therapy is known as photothermal therapy. What is that? It is the killing of a tumor using a laser and a nanoparticle. Nanoparticles are molecules that are so small that they can fit in the space between cells. Specifically, I work with nanoparticles called Prussian blue nanoparticles. Any fans of Bob Ross's paintings will have heard of that color before. And it turns out that when you shine a laser on Prussian blue, it gets really hot. So we harness that heat to kill tumors. More importantly, when cells die from heat, they actually release signals that can attract immune cells to that tumor environment. Unfortunately, that doesn't always lead to an immune response that will get rid of all the tumors in your body. So this is where my dissertation work comes in. I coat Prussian blue in these Y-shaped proteins known as antibodies. These antibodies are specifically meant to stimulate the immune cells that arrive to the tumor environment. And so I inject the nanoparticles directly into a tumor, and then we give those nanoparticles and the tumor photothermal therapy. Theoretically, what would then happen is the antibodies would activate the immune cells that arrive, and then those immune cells would go and destroy the tumors that have spread all over the body, with us only having to treat one tumor. So currently, my lab and myself have tested this in mice that have only one tumor. And we have been able to find that we can achieve a 50% survival rate for those mice when we use our nanoparticles, compared to 10% survival when you treat the mice with uncoated Prussian blue. Furthermore, those mice are actually resistant to any melanoma that we try to reintroduce to them. So our next goal would be to try and test this in mice that are bearing more than one tumor, and we hope that this work can serve as a foundation for the field of cancer biology to treat late-stage cancers. Thank you for your time.
Thank you, Jacob.